Some of the important factors which affect electron affinity are: 1. Nuclear charge. Greater the magnitude of nuclear charge, greater will be the attraction for the incoming electron, and as a result, larger will be the negative value of electron affinity. 2. Atomic size. Larger the size of an atom is, more will be the distance between the nucleus and the additional electron, and smaller will be the negative value of electron affinity. 3. Electronic configuration. Stable the electronic configuration of an atom is, lesser will be its tendency to accept the electron, and larger will be the positive value of its electron affinity. For example, the elements having completely filled sublevels of the valence shell have relatively stable configurations, and consequently, possess large positive values of electron affinity. Since experimental determination of electron affinity is not as easy as that of ionization energy, the sufficient data regarding electron affinities is not available. Consequently, the varying trends of electron affinities are not well defined. The electron affinities of some elements are given in this table. On moving across the period, the atomic size decreases and nuclear charge increases. Both these factors result into greater attraction for the incoming electron, therefore, electron affinities tend to become more negative as we go from left to right across a period. However, some irregularities are observed among the elements of Group 2, Group 15, and Group 18. The electronic configurations of these elements are relatively stable, and hence, these elements have positive or very low negative electron gain enthalpies. On moving down a group, the atomic size as well as nuclear charge increases. But the effect of increase in atomic size is much more pronounced than that of nuclear charge, and thus, the additional electron feels less attraction. Consequently, electron affinity becomes less negative on going down the group. Let us now examine the values of electron affinity for halogens, as shown in the table. It may be noted that the electron affinity becomes less negative as we go from chlorine to bromine to iodine. However, as we move from fluorine to chlorine, the electron affinity becomes more negative, whereas reverse was expected. This is because when an electron is added times to fluorine atom, it goes to the relatively compact second energy level. As a result, it experiences significant repulsion from the other electrons present in this shell. On the other hand, in chlorine atom, the added electron goes to the third energy shell, which is relatively larger. Hence, it experiences less electron-electron repulsion. Therefore, electron affinity of fluorine is less negative as compared with chlorine. Chemistry is an interesting subject. Keep unraveling its mysteries. See you in the next video.